Yep, this time it worked.
They might have seen this already.
Oh, yeah. He was in the classroom.
83.
How about you say it word?
I think he said it.
Yes.
That's probably about time.
Really? Check minus 2 to get the definition.
Gotta be connected to yours.
Oh, you shouldn't be having like that, child.
That's one different direction.
That's your problem, not mine.
This one, can I go get some water?
At this point, if you give me openings, I'm just marking them late, so I'm tired of this crap in my basket.
You see, that's what I did. I got, at least 6 of them. What? Ready? I'm about to shoot them. Hopefully you're ready to return. I missed it.
I'm probably gonna pay off at least 20.
I got it to open it. Damn.
Cause you won't open the door.
It's okay. I was walking. Just walking through.
And he said, there.
Sure.
What's it?
Alright, these are all out. Yep. Alright, let's finish up what we were doing yesterday. That takes care of all the papers that I have that I need to return to you, with the exception of today's quiz. And that I won't return right now because fourth period still has to take the quiz. All right, but we've gone over the answers. So we're going to finish electromagnetic induction, and then we're going to do some review for the test, and then we'll move on probably and start waves today. Now remember, I think I told you this yesterday, this is our last physics unit. Waves is the last physics unit, and once we do waves and we test on it, it won't be next week, it'll probably be the start of the following week. We're in chemistry for the remainder of the year.
Wow.
After we do waves. Because it's the last physics unit. Waves is it. Once we're done with waves, the last roughly 6 weeks of the semester is all chemistry.
So are we
Oh, so
gonna
we're
get
gonna do
another
it?
sheet like
Huh?
this?
Yeah, we got to do it. So, physical science is physics and chemistry. So you get chemistry too. All right. So yesterday,
So we would still take chemistry.
in physical science, we only skim the surface of a few topics. You're not getting chemistry like my second period's get. You're just skimming the surface of some topics. Okay? Now, yesterday we drew this picture, all right? And we labeled this as the left and the right, because we said we were going to talk about both halves. All right, and I made you draw a little needle because I said we were going to check for current on the right-hand side. All right, now, what did we say the left-hand side was? Does anybody remember what we called it? It's an electromagnet. When you look at the left-hand side, you have a battery, you have iron, and you have coils, okay? So this is an electromagnet. If you were here yesterday, you wrote this down. All right, now, when we run an electromagnet and we hook it to the battery, all right, what happens when current flows from the battery through that wire? What did we make yesterday when we did this? What happens when we run current through this wire, through those coils, and around this iron core? What did we make yesterday when we did this? We made a magnet, okay? Now, yesterday, we filled out.
Wait, can you go back?
Ooh,
Yeah.
Let's watch that.
I don't need it.
Wow.
I
So
didn't
why is
see
it up
it.
there if we don't need it?
Because we don't need it, and I'm going to get rid of it.
You need that.
No, we don't. There. Now it's not in my way.
But we know that it was there.
Well, it's not there anymore. Everyone, you ready for me to move on? Nigel.
Do I need to write the letter?
Huh?
Do I need to write the letter?
What letters?
The in blue?
It's up to you.
Okay.
Okay. Now.
Wait, is this gonna be long? How many stars you got now?
10.
We're on 18 out of 22.
So 4.
That's a lot.
All right. So yesterday we did this top half. All right. So we said, all right, if current flows through this side, okay, and we make a magnet here, what happened on this side? What did we say yesterday? Anybody remember? What did we write down? If electricity flows through this wire and we make a magnet on this side, what happened on this side?
It not produce current.
Okay. What did Faraday fail to get? No current was produced on the right. It did not matter how much current, all right, it did not matter how much current Faraday used on the left.
Well, why would it make current? It's kind of stupid to even think that would happen.
We're going to talk about how he did it in a second. I'm going to show it to you in a simulation. We used to be able to do a lab with it, but with the Chromebooks, the simulation doesn't work anymore on the Chromebooks. It worked really well on the computers that I had to give to Miss, well, it was Dr. Phillips that time, and they gave me the Chromebooks. It doesn't work on the Chromebooks. It doesn't run. Now, Faraday noticed when the current was turned on or off on the left side, the changing magnetic field produced a current on the right side. Okay? When the current was turned on and off on the left side.
Miss Wall,
Yes.
do you have Luis
Luis who?
Mario Resendez?
Yes, I do.
Can you send him to the office for a moment?
I will.
Thanks.
Welcome. Take the vest. All right. When the current was turned on and off on the left side, the changing magnetic field produced a current on the right side. You know, there are two of you now, so that's why I had to ask for specification.
What did you say?
The one that's never here.
Okay.
Well, they could have been checking on him or something or needing it. Gotta check. Is he planning to come back, Joseph, or do you not know anything?
He ain't coming back.
Just thought I'd ask.
Yeah, I don't know if I can disclaim on it.
Okay. You don't have to explain. I was just asking for a yes or no answer. Maybe would do.
Maybe.
Okay.
Everyone was scoring at 83 or higher on the exam.
Some years I get really close. Some years I don't. This will not be one of them.
Why? Who do you think's gonna pick? Never mind. Let me not ask that question. Just one.
So,
What are we waiting for?
Jose looked like he was still writing, so I was waiting on him to finish. I assume he's copying. Maybe he's just writing stuff down. I don't know. Am I waiting on him? Or are you just finishing? Well, then what are you writing? What are you writing? Stuff? I thought you were writing notes. Okay, I won't be waiting on you again. All right, so when you look at the left or right side, all right, so as long as current is flowing through here and we have a steady magnetic field, is anything happening on this side? No. But when we turn the current off and on this side, when we turn the current on and off on this side, the needle would move, okay? We would make a current. A galvanometer just measures current, okay? The needle would move, saying we got current on this side. When we turned it back on, the needle would move the other direction. So as long as we change the magnetic field, we could make power or current on this side. When it's steady on this side, did anything happen on this side? No. Okay? So what was Faraday's conclusion? All right? He concluded a steady magnetic field will not produce a current. A changing magnetic field will produce a current. Okay? A steady magnetic field will not produce a current. A changing magnetic field will produce a current. That's just the discovery he made.
Wait, so there's like, there's no reason for it?
A steady one won't, and a changing one will. That's what he found in his experiment. That if the current stays steady and you make a magnet, a steady magnetic field will not produce a current, but a changing magnetic field will. And I'm going to show you a simulation of that in just a second after we write down the definition. All right, so what is electromagnetic induction? What are we making by electromagnetic induction? What was he trying to make? He was not trying to make a microwave. That'd be really cool if he could, but that was not what he was making. What was he trying to make?
Current.
Okay.
Last night, my microwave fan turned on, and like, I couldn't get it off. I pressed the red button, and I unplugged it, and it turned off, obviously. But when I plugged it back in, the fan turned on again, and the microwave fan was running for like 20 minutes, and then eventually it just shut off.
Okay.
You need to plug it.
All right, so a process by which electricity is made. Now, what is the electricity made from? What kind of magnetic field?
Electromagnetic.
Need one more word.
Changing one.
By a changing magnetic field.
Isn't that kind of worthless though?
No, we use this for all kinds of stuff.
But if you use energy from the battery,
Huh?
if you use energy from the battery and make more, then what's the point?
Well, it doesn't have to be from a battery. That was just how he did the experiment. We use it for all kinds of things. I mean, most of our electromagnetic induction is made from a power source that's plugged in. Your refrigerator uses electromagnetic induction because it uses a motor. Your debit cards use electromagnetic induction. Your doorbell uses electromagnetic induction. If you have a car that has power door locks, it uses electromagnetic induction. Okay, that's just the experiment he used to discover how it worked. All right, have I got everybody with the notes? Because I'm not waiting on Jose because he's just writing. Jay, are you writing down what's on the board? Okay. Tell me when you've got it. Okay.
Can I get some water?
Sure.
Thank you.
It's not me. That is not me.
I was like, why are you being irritated over there?
What?
All right. Where is it? Oh, I think this is the one. Now, you'll notice that, all right, there's my bulb, right? If I just have a magnet sitting there, it's not the one I want, but it'll work. All right, if I just have this magnet sitting there, do I make any electricity? Look at the light bulb. What happens if I change the magnetic field? Do I make electricity then?
Yes.
Yes. Okay, I can make electricity then. All right, I gotta find the one with a sink, with a faucet. There it is. All right. So, all right, I have a magnet. I've got a light bulb here. I'm gonna turn the switch on. All right, here's my water. All right, now this is my magnet, right? All right, the magnet is steady. It's not changing. All right, the magnet's not moving. All right, I'm not making any electricity. So I'm going to turn this on so the magnet will do what? So the magnet will move. Now, as the magnet moves, what happens? Can you see any electricity there? Can you see the yellow lines?
Yeah.
That's the light bulb on. Now, what happens when I turn the water up? All right, the magnet does what? It spins faster or slower? Faster. What happens to my electricity when it spins faster? Do I get more electricity or less?
More.
All right.
Why does it like go off?
Why does what go off?
The light.
Because what I do to the magnetic field.
So
Is it steady or changing?
like whenever it's spinning, the light flickers.
Because light, if we could slow it down, all light flickers. It's a reversing circuit. It's alternating, right? So the electrons are moving back and forth. So all light flickers. It's just usually slow enough or fast enough you can't see. Okay, so if I turn that on, if I get faster, what happens to the electricity then?
It goes out the roof.
Yeah, it goes faster. Okay? But if it's a steady magnetic field, what happens? Is there any electricity? No. So it has to be a changing one. All right, so that's the way lots of electronics work in our house. So let's say that I have some examples for you. Now, some of these examples are kind of stupid. Okay, I'll come back to that last slide. All right, and I put some things that we all use: debit cards, credit cards. All right, speakers. Some of y'all have Bluetooth speakers. I do. All right, it uses electromagnetic induction. All right, most of us would not have what we have today without electromagnetic induction. Now, automatic sprinklers, and I don't know if any of us are independently wealthy. I'm certainly not. My grass either gets rained on or it doesn't. Markel, turn blue bloods off, take your earbuds out, and put it up. All right, but if you had automatic sprinklers, it would work based on electromagnetic induction. All right, for those of you who drive and have to go up to traffic lights, we get a little irritated when we have to sit and wait, don't we?
Yes.
All right, the ones that have the little lines in it that are the traffic activated ones that will turn when you roll up on them, those are based on electromagnetic induction. Any of y'all have battery chargers for your phones?
Yes.
Whether they are the ones you plug in for your phones or the old kind, y'all are probably too young, but the ones that used to be AC DC adapters, those were also electromagnetic inductions. Transformers, have y'all heard one of those blow up?
The movie.
The what? I wasn't thinking about the movie. I was thinking about the transformers for power and electricity. If y'all have one blow up by your house or close by and you're out of power for a couple hours, so they replace it. Have you heard one blow up? All right, transformers work on electromagnetic induction. Metal detectors, we don't use them here too much anymore. They used to be pretty commonplace at football and basketball games, but those also work based on electromagnetic induction. Now, basically, if it has a motor, it probably uses electromagnetic induction. Okay, those are just some examples that I wrote down. There are lots of others. Okay, I'm just going to put your phone up. I know. Roll your eyes. Huh? Okay, you just shook your head.
He said he was taking his own.
You what?
He was taking his own.
It's got a stable full, right?
Yeah.
Okay.
Just wait for it to get home.
All right, does everybody have what they want? All right, the last slide. All right, two things that we use all the time to use electromagnetic induction. All right, this is why I said if you have anything in your house that has a motor in it, why I said your refrigerator. It uses that electromagnetic induction. Okay? Now, a lot of times people struggle with what these things do. All right? My recommendation is know one of them and know the other one is the opposite. So I always remember the generator, and I know the motor is the opposite of the generator. Because what happens in a storm? What do you need a generator to do? Make electricity, right? So I know that it's a motor inside and it moves. So it's mechanical energy, and mechanical energy makes electricity, electrical energy, right? So I know the motor is the exact opposite. So it's got to go backwards. So if I know the generator is mechanical to electrical, then the motor has to be the opposite. So I know that it's electrical to mechanical. Now, if you're a car person, and I sort of am, but not really, all right, motors go from electrical to you got to move. Cars drive you around, so they become mechanical energy. They move you from place to place. But both of those are examples of electromagnetic induction. Now, the motor doesn't necessarily have to be a car. Tyler was here. We could use him as an example because what he just get.
Zero.
What's he been talking about for 2 days? A moped. See, Elizabeth and who was it? Was it Najee? Is that it? He got a moped. Oh yeah, he's been all excited about a moped. Trevor could probably tell us about it too because they've been talking about the CCs because he told us it would go up 70 miles an hour. All right, and somebody did something to soup it up. He was happy about a moped. He's got transportation. He's a little scared of it, but he's got a moped. So we can talk about his motor in the moped. Uses electromagnetic induction. It doesn't have to be a car. Okay? Go ahead. And pop a wheel. Okay? But it doesn't have to be a car. It could be something else too. All right? Questions? Yes? No?
No.
Not.
No.
Fabulous. We're going to take a few minutes to work on our review sheet. I'm not giving you very long today, about 15 minutes. And then we're going to do either a Plicker or a Kahoot. And then we're going to move on to waves. I'll make Markel hand it out. You feel better today. My skills kicked in. You're all feel pretty good. Because I think I put Plicker stuff in the computer.
You did what?
Let me see. I don't think I have a magnetism.
Bro, we gotta get tricky. Everybody in here did that? Nobody?
Nobody what?
So we gotta get swifty.
And remember, this is the one I grade.
You gotta get something.
Thank you, Markel. Thank you. All righty, so. Go. Time me some answers. Period. Yes, I put my questions in there.
It's water.
Yeah,
When do we learn about horseshoe rings?
a horseshoe magnet's like any other magnet.
We're on a farm.
Bar magnet's one we've been using. I can pull out a horseshoe magnet if you want to see them. I have a couple.
So are the poles the same for both?
Yeah.
And I didn't see.
I could come to school, that's all I'm gonna do. Why you come to school, that's all you're gonna do. Take that back, I'm only have one horseshoe magnet. Nope, I got two. Anybody else want to say one? Oh, yeah, your Simon.
Oh, these.
Yeah.
These are weak.
Yeah, they are. They're old. That's why when we say permanent doesn't mean permanent. It just means for a long time.
So these are.
Those are probably, let's guess, middle 90s, 96, 97. Yeah, they're old.
How old are the ones that you had? You were the
Those are probably just as old.
on bar bag?
Yeah.
They also.
They could barely hold a banana.
Yeah, I'm not surprised. They're old.
Why don't they go together? Show me. What happens when you cut a bar magnet in half?
You get two new magnets.
So like where the middle was turns into a new south and north?
Huh?
Like where the middle is, it turns into a new north and south?
Uh-huh. Yep. You get two new north and south.
This one.
Yeah.
I give it back and I see my quiz.
Yeah.
What's the song gonna be?
Huh?
What's the song gonna be?
It's a long coil of wire.
Oh,
You know that wire you wrapped around the nails yesterday? That's the solenoid, the wire that had the coils in it.
What is the compass going on?
Say what? I didn't hear you, Nigel.
never mind.
Anybody finished?
Yeah.
Are you sure it's driven?
I don't know why it gets the fuck in there.
A magnet or electricity runs a wire. They just leave a package at the door.
Nobody.
Okay. Here, Nigel, you can have it back, I'm done. Sorry. Are you done? Integrate. Done? What's that? A magnet. Or current, like, comes through like a phone charger or something that's plugged in.
What was another use of practice? Electromagnetic. I got four.
This is very weird. I don't know what you have, so it's hard for me to give you another one.
This wall.
I have to follow the directions. It's hard. It's hard. All right. Here.
Wait a minute. I thought they were supposed to repel. North should repel, right?
They should.
Why are these sticking?
Because they're really bad magnets. There's a couple back there in the stack that I put in the cabinet that say north and north that will still do that. Observation number 2.
Look at the south and south.
Observation. Acknowledgement number 2.
Right there, in this cabinet?
Oh, I don't know.
That's not that one.
There we go. Nope, that's not. Never know. So you know what it is? It is the noise of the TV.
Where's the other magnet?
The other ones are behind Joseph in the cabinet.
What is
What was that? Nice deal for me. Wait, can you set like a bunch of paper clips on a magnet, and then when they get magnetized, like throw them on something?
So what? Tell me what you said again. I was answering Miss Harvey.
Like if you set a bunch of paper clips on a magnet, right, and then take them off whenever they get magnetized, you can just throw them on something and they'll all stick.
Theoretically, you can magnetize paper clips and they should stick together, yes. But if you then throw them down really hard, because they're not going to be magnetized very well, they will probably lose their magnetism. So, yeah, no. The magnets, you wanted the bar magnets, they're down on the next shelf. Yeah.
Let's do it.
All right, can we play the Kahoot?
Can I get some water?
No?
I can't.
No.
What?
There's like a.
Yeah.
I need help on the
Number 16 is current running through a wire or a magnet.
You
Can you repeat that?
Current running through a wire or a magnet. That's one that asks what will make the compass move, right?
Yes.
Yeah.
I think that's on a fire truck. Hey, what is it?
What is what? It's a weight. What y'all were just looking at?
Was. Whatever that was.
It's a weight.
You got so many coolies. We should put that stuff up. I said you could get a magnet out, not playing the game.
Well, I'll put it back at.
Back where you got them.
I don't know where I got, like, I didn't get them.
Those were in the, and there, you just lay them on the counter and I'll put those up.
Oh, something's erupted. Yeah. Oh, can you make a Marxism?
No, I can't.
You can't walk.
Oh, because I know my house.
Oh, gosh, you can't say that.
So, man, I made aspirin in college, but I don't know how to make a box.
You made it after?
In college.
Like, oh, never mind. Duh. We had to do chemistry.
I need to get this on like everything.
This shit is huge.
Which one more?
At first, because I had to speak on the table, at first he like his paws up and was like, and then whenever like the bass was started, it flipped off the table and like ran under. That man was terrible. And you don't understand how fast he got off of that table.
And that other one we're watching now, the big one. I want to keep them like, I don't know.
A reason you came to there?
Huh?
Is there a reason you came to there?
Yeah.
All right, have I seen everybody so we can play the Kahoot? Who wants to show it to me? I wanted to play the Kahoot.
No. I'm sorry.
Okay, we can go on and talk about waves. I'm good with that too.
I was joking. I kind of do need that Kahoot because like there's some stuff down on. I made you.
Here, Dion, come on. Unlock my cards.
Hold on, let me get you. Hold on.
Anybody else want to show me theirs?
Just a bit.
Well, she was still two poles. Won't matter, it was still two poles. Right there.
I feel like white. I don't know. I think I really do have the white. It might just be funny.
As you showed me yours, right?
Yeah.
Stop. You know the answer, you do it yourself. This ain't my answer. I gotta stop picking on you. I wonder if I can edit the music out. But you're gonna come That's fine.
You could have just let me do all that.
We got to edit that out.
What are you looking for?
All right, those of you who are playing, put your name in there because I'm getting ready to start it.
Wait.
I'll put the number on the board. And I have these in about 20 seconds, so these are going to roll pretty quick.
How many questions are there?
I think it's 18. Yeah, it is. Electricity moving through a wire creates a what?
An electric field. That doesn't even sound right.
Good.
How many people playing?
There's only like 6. What does increasing the number of loops of a wire do?
Wait, does the wire stay the same?
Good. If you increase loops, it'll make it stronger.
Oh.
Whoops.
I knew it.
All
I was
right.
the only one that got it.
The solenoid is the long coil of wire.
I just didn't.
The electromagnet is the combination of all of it.
I just saw the
Okay.
I see
wire.
everything before and.
Okay. Get next.
You would be like true or false?
What?
North and South Dakota.
I was so confused.
States.
Carolina.
States.
It's Carolina.
I think it's terminal.
North Dakota.
I think it's
Who picked it up?
Told you.
The word I was thinking of is not up there.
What were you thinking?
Electromagnetic.
Yeah.
That's not true though.
Next.
It just doesn't have to be. Wait, that
Yeah, well, it could be ferromagnetic, yes.
the North Pole. The center.
I wasn't even reading the question.
Really? Why not? Man.
I was sitting over here dancing. Look at my best life.
Okay, now.
Now you know it.
Now I should get it right.
What you listening to?
Uh,
What you listening to?
let's see.
And whichever one of you heathens is giving Mario the answers and sending pictures of your work to him, stop. Make him do his own work.
The last person.
Right.
As soon as this is over, Nigel.
All right.
Rain.
The class is fun. Well, who is number 7?
Apparently somebody who joined is not answering now because we have to let all the time tick off.
Somebody
Well,
in
I'm
here
just
knows
pressing
who they
the,
are.
you know.
All right, so it's a magnetic field. Okay, that's the area around it that you feel attracting or repelling.
Third place.
Okay, remember, a domain is inside.
So inside the magnet.
Domains are inside. Remember what we said about a motor. Changes into what?
Just press skip. Press skip.
Okay, motor has to move, so it becomes mechanical. What is decreasing the current due to the strength? Good.
Hey, all
Settled
7 people
person.
answered.
Just made it that time.
Who has the least amount of points? Just look. Which of the following material? Glass. Oh.
Copper. Nickel.
I was looking to see if there was a G up there.
Realizes you said the answer out loud, so says it.
Got everybody this time.
I want to pick it.
To be honest, I'm an animal.
I don't know what this one is. I didn't know.
A generator has to make what? What's the purpose of a
What
generator?
does it generate?
When do people use it? It makes electricity because you want it during a storm when you don't have power.
I know. Calm down, Miss Wall.
Wait, what?
I didn't even read the question. I just clicked on it.
I think I got it.
I know what it was.
That's what I know was right.
This is what we did today.
Oh,
You generate
Oh,
electric
then I got it
current
right.
by
I didn't know-
moving
I didn't know
something
what
through a
the-
magnetic field.
I ain't know all about the other thing was, so
So it's you? Nah.
that's interesting.
We didn't do this one. I left it to
What is
see
it?
if you would know it.
I know what it is.
I don't.
Just on quick.
If we didn't do
If you
it,
think
what's
about
the
it-
only word we didn't do up there, and think about it logically, you should be able to get it.
If you think about it, what changes
Just get it
things?
right. I got it.
All right, transformers raise and lower voltage.
It
Okay,
transforms it like.
I got it.
No.
Yeah, that's not
Oh no, this could be 2 of them.
nope.
Or
I
like
gave you this
in
definition.
my head, it can be.
Okay,
We watching snow. Is what it is.
my marker up.
Oh, I stole this from Mr. Joseph, actually.
We give it back to Mr. Kessel.
I didn't know I had it in my pocket. I didn't know it was in my pocket. Smack.
It starts with E.
My phone turned on, bro.
Look at you.
Yes.
Or went to sleep.
So
No, it was.
All right, remember, a magnetic domain has to be inside the magnet.
That's-
That's what makes it different.
You do know.
Magnetic fields are outside, magnetic domains are inside.
Everybody get it wrong except for me. Oh, no. I get back to third place. All right.
Last question.
Maybe
Oh, snap.
they didn't spell permanent right,
Yeah, they did.
What,
but I made you look at it to
I'm
double
about
check,
to
right?
get mad. I'm about to get very mad.
All right,
What's that, G?
if you hit get results, we'll do top 5.
Hey,
top 5.
Yeah. Who is Jiggy Jr.?
All right. All right, if you got a laptop, put it in the carts. If you have your review sheet done and you want to show it to me today so that it is finished and you've got your grades so you don't have to worry about losing it,